Hey, hi. In this video, I will show you how we can configure Ingress service on AWS EKS cluster. Yeah. So in general, as you know, so Ingress service is an object which sits in the EKS cluster or any kind of Kubernetes cluster, which is act as a service, right? Which will help us to configure the rules on the services of our original services of our Kubernetes cluster, right? So what these rules routing rules tells all about is saying like the how the users, nothing but a client who is outside the cluster, can access the services. Yeah. So especially how do we route the https and https traffic from the clients to the services which is hosted in the Kubernetes cluster. Okay. So that's what this ingress service is meant in Kubernetes world. Yeah. So in this demo, I will just focus on like how we can configure this service on an example AWS EKS cluster, right? Which is represents a Kubernetes cluster, yeah, in general. So as you see in this picture, this is a pictorial overview of my demo, right? So where a cluster that is a AWS EKS cluster here, which is again a managed Kubernetes cluster, right? So this is the cluster as you see. So this particular rectangle box represents my AWS EKS cluster. In that one, we have the pods, right? So pod is nothing but like which is hosting our applications, and then it exposes the services, right? The container will expose us the services, which is nothing but a kind of business logics, right? So now, how do the user? So the user who is sitting in the internet, and I mean the person who is sitting outside the cluster, right? He will be accessing our services, which is hosted in the EKS service, right? So that's where the egress service comes in picture. So the egress service is again, as I explained, you can think it as an API object which sits in the cluster, and it will maintain some certain routing rules, nothing but traffic routing rules, right? So that kind of capability will be provided by this service for the Kubernetes cluster, yeah. And again, so this ingress service is again depending on ingress managed load balancer. Okay, that's where the you see, right? So here what we do is we will put AWS, that is ALB, that is application load balancer here, which will again route the traffic to the ingress, and ingress will again internally check at the routing rules been configured on the Kubernetes cluster and passes the request to the respective parts. Yeah. So that's what this services provides. This services capability provides all about. Yeah. So now, so this is just a brief about my demo. This is just a brief about my demo and also about the ingress service. Let's go to the quick demo. Yeah. So to set this particular configuration, what I did is I have noted down all the required steps that you need to follow. That in this help file.json file, and the associated file, all the associated file and the command file will be shared to my repo, and the repo link will be shared to my YouTube videos, to this video's description. Okay, please find these files there as well. Yeah. Now, okay, before I jump to the steps to be performed in this demo, let me give a kind of a concrete definition of what is Kubernetes Ingress is all about. Okay, probably this would help you in your interviews or probably in general discussions. Yeah. So Kubernetes Ingress is an API object, as I explained, that provides a routing rules to manage the external users' access to the services in the Kubernetes cluster, typically via HTTPS and or HTTP. Yeah. So that's it. It's a simple definition that you need to keep in mind. Yeah. Okay. So as I said, like I will be spinning up an AWS EKS cluster. So let me go to the my AWS account. So this is my AWS account, yeah, where I have already pre-created one example EKS cluster. Okay, so this is just a blank AWS EKS cluster which is up and running now. So in this cluster, what we do is we configure the ingress service, and also we will host an example Kubernetes application on this cluster. And let's see how the ingress service caters the request from the clients and exposes nothing but allows us to do the business logics on our application. Yeah. Right. So to save the time, what I did is I have articulated all the steps that we need to follow in general. What are the commandlets I need to run to configure the ingress service on this AWS EKS cluster, and also how we can host an example applications on the EKS cluster. Okay, so that's where. So from here, our steps will start. We need to create an EKS cluster, which I have already pre-created, because creating EKS cluster on the AWS account will take almost 15 minutes, right? So as you see in this PowerShell, okay, so I'm running all those commands in my PowerShell window, whereas you can choose a CMD or Visual Studio Code based PowerShell as well. Yeah. Here what I did is, again, yeah, so I set the context of my account by using the command AWS CLI command called AWS configure, where I provided the access key, secret access key, reason, and the output format. Okay, finally I validated whether I have set the context by running the command called AWS STS get caller identity. Then I'm creating my required EKS cluster with using EKCTL. Yeah. So here, as you see here, EKCTL again is a Amazon given Elastic Kubernetes Service command line tool. You need to get it installed in your system before you use this command. Yeah, that becomes a prerequisite. Okay. So before I jump next, so prerequisite here is you should have your system EKCTL installed, and the next one, you should have your system installed with the Helm. Yeah. If you want to know how you can install the Helm charts in the Windows 10 system, please do watch my previous video where I have explained everything from the scratch around this one. Yeah. So now with this one, we are done with the first step, that is to create the EKS cluster. Okay. The finally, as you see here, it consumes nearby 15 minutes to make a EKS cluster up and running fine. Yeah. At the end, it will tell you a message saying like your EKS cluster with this name in this region is ready, up and ready. Yeah. Then what I did is I just run this command to check my status of my my account. Yeah. So what did I run is, again, I run the EKCTL command get cluster. The name of my EKS cluster is EKS Ingress demo, and the reason is US East 1. Yeah. And you see the status is active. And also if we go to our portal, we see the status equal to active. Okay, this is my EKS cluster. Yeah, let me open this. Right. So now we are here. Now let's go to the next command. Yeah. So in next command, what I did is I'm just validating whether the EKS cluster is up and running. Okay. So with that note, let's go to the next steps. So in next steps, what do I need to do is we need to create IAM IODC provider. IODC provider is nothing but Open ID Connect. Yeah. Open ID Connect kind of provider. Okay. So that is a prerequisite for this demo. So that's the reason we are creating this IAM OIDC provider pointing to this particular cluster which we created. Okay. So let me copy this command and put it here. Looks like it didn't copy. Let me copy it again. So if you are trying this demo in your side, please do follow the same steps whichever I have been told. Okay, I'm just demonstrating here. Yeah. So here again, I'm using the EKCTL utils. Okay, and the command, the API which I'm using is associate IAM IODC provider. The reason is this one, and here I'm pointing to my EKS cluster and giving a flag called approve. Yeah. Now let me do this. So I have just entered. It's currently, what it does is it will configure the IAM IODC provider on my EKS cluster. Yeah. So the process is very fast. It has successfully created. Okay. You see the message saying like the created the IAM Open ID Connect provider for this cluster, which is sitting in the location US East 1. Now with that note, let's go to the next command. So next command is creating a IAM policy, right? Ingress configuration requires IAM role, a service account, and an example IAM policy. Okay, when I say example, in the sense it contains certain actions to be allowed. Okay, so let me quickly walk you through this IAM underscore policy.json file before I run this command. So this is how the file looks in place. This file will also be shared into the same repo, and the repo link will be shared in my into this video's description. Okay, please find there. Yeah. So here you see, right, I have it allows multiple actions. One is it allows EC2 related and elastic load balance related actions are being allowed here. Let me go to the next one. So it also allows the ACM, IAM, and WAF regional, yeah, and WAF version 2 shield. Okay, so these are the API actions are being allowed. Similarly, we have the further allowed EC2 actions. Likewise, okay. Likewise, it allows the required. Amazon or AWS predefined actions will be allowed by this policy. Okay, that's what we are doing. Let me not go in depth about this policy, but whereas I would encourage you to study these those actions before you run this command. Yeah. Let me run the next command to create the required policy in my AWS account. Right. So I have not copied that command. Let me copy quickly. So I'm copying this command. And what it does is it will create a policy. Okay, it will create a policy. It says that, right, can you try to identify why the issue is happening? It says that it's trying to find the JSON file, that is IAM policy JSON. It's not able to find under current working directory, PWD, that is present working directory Resnas has this IAM policy. That's the reason this error will be thrown. Okay, you need to understand why these errors occurs. Okay, that's very important. Okay, now let me go to the folder where I kept all those files. Okay, so I need to do a cd to this path. Yeah, then let me run this command now. It should work. Yeah. So again, so it is very quick. It has successfully created a policy for us, which is required for this demo. And the next step is I'm creating a IAM role and service account and linking that to my the EKS cluster which we created. Yeah. So let's do that. So here, let me go to the command. Again, we are leveraging the ekctl command line utility. Create IAM service account. You see, right? The API is IAM service account, and for that one, we are using the create. Yeah. And the cluster name is the EKS Ingress demo. Namespace is kube system. Okay, you see, right? I'm configuring this service account in the kube system namespace of my Kubernetes cluster. Yeah. And the name is AWS Load Balancer Controllers. Okay, that's the name of my service account. And policy attached is the policy which I created above. Yeah. And giving the flag equal to approve. Let me do that. So what it does is, as I say, in the EKS cluster, it will create an IAM service account and attach the policy which we created above. That's what it does. Okay, as simple as that. And why we are doing this? Yes, this is the predefined steps from the AWS account, AWS side. We need to follow this one. Okay. And what this service account does is, it will, with this service account, you are making your EKS service to have that permissions which is defined in the policy. Okay. And in simple layman's term, you need to understand something like this. Yeah. So while it takes to finish this this command, let's go to the next command to run. So next one, what we need to do is we need to install the target group binding, that is CRDs. Yeah. So what I do is I will run this command and let's finish up that requirement as well. Yeah. Here you go, right? It has successfully created a service account for the EKS cluster. Okay, for our EKS cluster. Now let's go to the next command quickly. So where it creates a target group bindings. Okay. Here we are pointing to some GitHub account, which is again shared by the AWS itself. Yeah. So let me run this to perform the group binding. Yeah. So command is kubectl. Here now you see there is a difference. Earlier we were using kubectl, ekctl. Now we are using kubectl. Yeah. And I'm using the command API pointing to this particular repo. Yeah. So let me do that. Then let's go to the next one. Next command to view the CRDs. Okay. It's running now. So while that command is running, let me go to the next command and try to find out, okay, what we did. So next command comes about the Helm utility. Okay, as I said, we need to have the Helm utility because we are leveraging the Helm charts to install the AWS load balancers. Okay, on the we are leveraging the Helm charts to make the AWS load balancer, that is ALB, to make a connection with the Ingress service, which will be sitting on the EKS cluster. Okay, that's what the next command will do. Yeah. So let's see if this command is completed. Okay, it's taking some time. So here next command, what we are doing is we are adding the EKS repos, EKS Helm repos to my local laptop's repositories. And then what I'm doing is I'm configuring the AWS ALB to sit in front of the ingress. Okay, so that's what the next command will do, and we are using the Helm utilities there. Yeah. While it runs, let's complete the next following steps as well. Right. So next one, as I said, to configure the ALB. Once that is done, what we do is, yeah, we will roll out the status. Okay, nothing but we will check what is the status of the particular AWS load balancer controller. Okay, so as I explained here in this picture, right, configuring the ingress service, just a blank ingress service, if you configure in the Kubernetes cluster, that is no use. Okay, because somebody needs to control that service. Okay, nothing but somebody has to be in front of the egress so that the user can particularly invoke that ingress managed load balancer, so that the traffic only so that the traffic can be invoked and which has to be satisfied with the routing rules. Okay, so the traffic initiates from the client, it will initiate from the client to the ingress managed load balancer. From there it will go across the ingress where the routing rules will be evaluated, and finally once the rules are being evaluated true, then the service will become available for the particular traffic. Okay, then only the particular request will be catered in that case. Yeah, that's what happens. That's what it happens. Okay, so as you see here, we have successfully ran the next command, that is to configure the Helm the targeted group bindings. Okay, so next command, let me do the this one, where I will be cloning the EKS repo locally, that are Helm repos. Yeah, so it's already, so I have already configured those. That's the reason it says already exist. Let's go to the next command. As I say, it's to configure the ALB, okay, which will be sitting in front of our cluster. Right, let's go this. This is a big command. Let me walk you through this command as well. Here we are using the Helm utility upgrade. Right, we are using the upgrade API, and where I is equal to the indentation, right? So which is it is using the AWS. So okay, this is the indentation. Yeah, that is AWS load balancer controller is the name which I'm giving to that. Yeah, that is a release name. Okay, that was this is in general it will be called as a technically it will be called as a release name. Yeah, and this is where the Helm chart name is all about. Okay, EKS / AWS load balancer controller is the Helm chart name, and the name where is the namespace is the kube system. Yeah, which is a built-in namespace. Yeah, and the next cluster name is nothing but our EKS cluster name. Okay, and the set, what we are setting the service account create. Yeah, create equal to false. Okay, then the service account names is pointing to our AWS load balancer, and we are setting the image tag equal to v.2.0. Yeah, so now let me run this command. As I said, it will configure ALB, that is AWS application load balancer, in front of our ingress service. Okay, it will, while it takes some time, let's go to the next command. So next command is to check the rollout status, in the sense check the what is the status of that AWS load balancer. Okay, that's what the next command does is all about. So once we are done with that command, we have successfully configured the prerequisite before you configure the egresses. Okay, so let me tell you what are the prerequisites. Okay, one is you have created the EKS cluster. After that, we have created the policy. After that, we have created the IAM role and the service account, and binded that service account with the policy which we created above. And after that, what we did is we install the target group binding CRDs. Then after that, we are creating the AWS ALB, that is application load balancer. Yeah, and finally we will be checking the rollout status of the ALB. Yeah, that is AWS ALB. Here you go. Right, it has successfully, this Helm upgrade deployment has went successfully. You see, this is the name we have given to our deployment, and the namespace is kube system. The last modified date is something like this, and deployed state is equal to successful. Deployed in the sense success. Revision is equal to 1, and test suite equal to none and note equal to none. Okay, so you says the AWS load balancer controller is installed. Okay, so nothing but we have successfully installed this component. Okay, now what we need to do is we will be configuring this service. Okay, and also we will be configuring these rows. Okay, these parts. Yeah, now these parts will be configured. Whereas while these parts are also getting configured, we are also making sure that these components will be getting spinned up along with these services as well. Yeah, and so when you say, so there are multiple components are getting spinned up here. Let's see how we are doing that. Yeah, next step is to just to validate the rollout status of our AWS load balancers. Okay, so let me do that before I run the original command to create all our ingress and the other related components. So let's evaluate it. What does this command gives output is it will just show us the status. Okay, you see, right, it has successfully rolled out. Yeah, that's what we want. Now let's go to the next command, that is which deploys a sample application. Along with that, it also configures the ingress. Okay, so before I run this command, right, you need to make the CD path. Okay, again you need to make a CD to this path where you have kept this sample app.yaml. You see, right, so this is my path where I have kept sample app.yaml file. Before I run that command, let me quickly walk you through this. Here what I'm doing is, okay, here actually all the cluster configuration is happening, right? You see inside the cluster we have in general 5 components. In the sense we have the ingress. In the ingress we are configuring the routing rules, we have the service, we have the pod deployments. Okay, so let's see how we have defined in this YAML file. Yeah, here let me scroll it bit up. So as I said, first one, we are creating a namespace, right? And the name of the namespace is we are giving just game-2048. So I'm just installing an example 2048 game app into this Kubernetes cluster, right? So that's the reason what I am doing is I'm creating the namespace here. And finally, next one, the next command, right? There's a separation. You see that triple hyphen as nothing but you're segregating the components. Okay, so first one we created a namespace. Next one we are creating a deployment, right? You see the kind, right? Kind is nothing but what is the kind of deployment? Yeah, what is the kind of task it is? It's a deployment. So what we are doing is we are deploying a particular one kind of image, nothing but we are deploying a kind of app. Yeah, and this is the image which we are deploying. Yeah, so next one, we are creating a service. You see, right, this is the service which we are creating, and the name of the service is something like this, service-2048. It's again a game app name. Yeah, and you see the type is node port. Okay, there are multiple properties and specifications are being defined for each of the components. I would again encourage you to go through this. Okay, so again finally, so this is very important component. You see, right, the API version we are taking note is here is networking.kubernetes.io/v1 beta 1. Yeah, and in the metadata block we are giving the namespace name, annotations. Okay, we are giving some multiple annotations. These are very important annotations. Okay, which this ingress service will be referring for deployment purpose. Okay, make a very important note. Yeah, so it has to be mentioned something like this only. Yeah, don't alter this while you are trying. Yeah, kubernetes.io/ingress.class where it is using the ALB, that is AWS load balancer, right? ALB ingress.kubernetes.io/schema, it's again internet facing schema. Similarly, target type is equal to instance. Yeah, right? And finally, so this is where you are configuring, you have created a service, a API object called ingress, and after that here is where you are specifying the rules of the ingress. Okay, here we have defined only one rule, right? What is the root? The rule is pointing to the HTTPS traffic. Paths, in the paths we have defined only one path, that is the root / nothing but whatever been defined after the root. Yeah, so that's the reason / star has been mentioned. The backend is nothing but where is it pointing to? It is pointing to a service which we created here, right? And which port it is? The port number is 80, right? And that's what we have defined here. Here the kind is service, metadata is the something like this. Yeah, and ports is nothing but ports is 80, target port is 80, protocol is TCP, type is node port, selector is nothing but our kubernetes.io /name and this one. Yeah, So this is where this, if you understand this clearly now, if you have followed the whatever the things I have explained here, you should be now connecting the dots here, right? Where we are creating the ingress, and after that we are configuring the routing to that particular ingress, and it is pointing to a service, and the service is again related to our parts, nothing but our application. Yeah. So now with that note, let's go to the and run this command, okay, which will does the required stuffs for us. Yeah. So the whatever the components I have explained there is now getting provisioned at our AWS EKS cluster, right? You see the namespace is created, the deployment is created, the service is also created, the ingress is also created. Okay, you see that there are 4 components are being created here, right? First one is namespace, deployment, service, and an ingress. Yeah, and the name of our ingress is ingress-2048. Yeah, that's the name of our ingress. Right. With that note, let's go to the next command. So now let's verify what is the status of our ingress service or ingress API object. So let me do that. I think I didn't copy properly. Let me copy again. So what I'm doing is, since we have provisioned the ingress service, let's evaluate what is the status of that ingress service. Yeah. So the command that is, again, I'm using the kubectl get ingress /ingress for ingress / name of the ingress, and the where is the namespace. Yeah. So this is where it says, right, the name of the ingress is ingress-2048, and the address is nothing but this is the address, which is again AWS ALB, that is AWS application load balancer. Port is 80, and the age is nothing but when it has been created, that is 53 seconds ago. Yeah. So that's it. We have successfully configured the required components, and finally let's retrieve the URL which we need to invoke in the internet to access the service. Okay. So let me copy again. So let's see what is the output. So now you see, right? So this is the address. Yeah. So this is the address of our the ALB, which is again pointing to our ingress service. Yeah. So how do we retrieve that? Let's say you want to retrieve that the address explicitly. We can do that with using this command. Yeah. I think it's not getting copied properly. Let me copy clearly. Yeah. So let me point it here and copy strongly. Yeah. So and let me put it here. So you see, right? kubectl get ingress and the name of the ingress and the name. Yeah. Then the output is nothing but a JSON path. In that one, we are retrieving the host name property. Yeah. Status load balancer dot ingress. In that one, we want the 0th item of the array ingress and the host name. Okay. So this is what the URL of our AWS ALB. Yeah. So that's it. We have successfully configured the required components, which I have shown you here, right? So nothing but what we did is we created the EKS cluster, and we also created the AWS ALB, that is application load balancer. And finally, we spinned up the complete EKS cluster component, which includes ingress service. We configured the routing rules. Then we configured a service, which is pointing to the application which is running on the pods. Yeah. And finally, we retrieved our AWS application load balancer FQDN. Now it is time to invoke this load balancer FQDN and try to see if the application is working and run. Yeah, is able to accessible. As I said, as we defined here, right? If you see here, if I go to the ingress, right, we have defined the HTTP, right? So in the sense, this application will be accessible from the client. The client is the person, nothing but person who is sitting outside the cluster, nothing but from the internet, he will be accessing that particular AWS load balancer FQDN, and that would invoke our application as well. Yeah. So let's do that. Let me copy this URL. Since we have defined it on HTTP, so we should be able to access that only through HTTP. HTTP, not HTTPS. Let's first show you with the HTTPS. Okay, let me show that it should not respond. Let's see, okay, how it responds. Because here, if you see, I have invoked with HTTP, yes, okay. But in the rule, you see, right, in the rule we have given HTTP only, right? And port number is 80. Yeah. And let's see how it responds. Okay. Parallelly, let me access it as HTTP as well. HTTP only. Okay. Not HTTPS. And let me invoke it. One side it is invoking the HTTP, which is right. You see, right? In a tab where I invoked via HTTP:// our ALB FQDN, you see the application is running up and running fine. Okay, this is the application which is now running in this EKS cluster. Yeah, right. And the other side where to show you as an example, you see that the site is not reachable. In the sense, if the person is trying to access as a HTTPS, the service is not available. In the sense, user has to have invoked that service with using HTTPS annotation only, HTTP annotation only. Okay, then only the service is getting available. Yeah. So that's what. So this is how we restrict the users to access the service with using either HTTP or HTTPS modes. Okay, that's it. Okay, finally I have successfully shown you like from the scratch to end, saying like how we will be configuring ingress configuration on our example AWS EKS cluster. Okay, so that's how I have successfully shown you from scratch to end, which is need to be shown in this demo. Yeah. Finally, thanks a lot for watching my videos. Kind request, please do subscribe my channel. That would really encourage me a lot. Okay. With that note, thank you. Thanks a lot.